Kirchoff's current law. Hello there, welcome to Masomo Smart Online School. Today, we are looking at a topic that cuts across physics, electricity, and electrical engineering. If you're a student studying either of these subjects or courses, then this is your content. And the topic we are looking at is DC circuit theory, the Kirchoff's laws, particularly the Kirchoff's current law. So the Kirchoff's laws are laws that are used to determine the current and voltage drops in DC networks. They are laws because they are normally two. We have the Kirchoff's current law and the Kirchoff's voltage law. But in this session, we are concentrating on the Kirchoff's current law. So the Kirchoff current law states that at any junction in an electric circuit, the total current flowing towards that junction is equal to the total current flowing away from the junction. I'll state it again. It states that at any junction in an electric circuit, the total current flowing towards the junction is equal to the total current flowing away from the junction. Let's look at that in an electrical circuit diagram. We have three currents flowing towards the junction and two currents flowing away from the junction. So we have I1, I2, and I3 flowing towards the junction, and then I4 and I5 flowing away from the junction. And so to represent that using the Kirchoff's current law knowledge, I1 plus I2 plus I3 is equals to I4 plus I5. Or we could rewrite that into I1 plus I2 plus I3 minus I4 minus I5 is equals to 0 because all the current should cancel out to 0. How do you know the direction of the flow of current? We said that I1, I2, and I3 are flowing towards the junction. The junction is the dot at the center where all the currents meet. And you can see the arrows in I1, I2, and I3 are pointing towards the junction, whereas the arrows in I4 and I5 are pointing away from the junction. So the direction of the arrow indicates the direction of the flow of currents. So let's look at a solved example and try to apply the Kirchoff's current law to solve the missing currents, or to determine the current that is missing. So we have four currents and they are meeting at a point that we are marking right there. So I1, I2, I3, and I4. We have been given the values of the currents. I1 is equals to 2 amperes. I2 is equals to 9 amperes. I4 is equals to 4 amperes. And we are supposed to find I3. So we are supposed to find I3. How do you think we will solve this? Of course, we are applying the Kirchoff's current law to find the solution. So according to the Kirchoff's current law, the total current flowing into the junction is equals to the total current leaving the junction or flowing away from the junction. So I1 plus I2 should be equals to I3 plus I4. We can relate that with I3 as the subject of the formula. So I3 will be equals to I1 plus I2 minus I4. Then put in the numbers because we already have the values of the currents. So I3 will be given by 9 amperes plus 2 amperes minus 4 amperes, which will give us 7 amperes. So the value of I3, or the current flowing through I3, is 7 amperes. I hope you understood the content. So you could check us out on all social media platforms and of course on YouTube. You can also visit our website www.masomosmartonlineschool.com. See you in the next video.